Hello guys, listen to this. Spectra Suite has released 54 models in one breath. Yes, you have heard it right. They have come up with 54 models, and out of those 54, 18 already are present on Hugging Face. And out of those 18s, we are going to install two of them locally, and then I will describe what exactly is the difference between all of this. Spectra Suite has done what we were expecting the companies to be doing for a long time now. And 2 to 3 months are really a long time in AI. So, what they have done is they have trained and open sourced a bunch of ternary and floating point 16 models, and they have done an exhaustive analysis of these models on common sense and reasoning, knowledge and toxicity across the scale. These ternary models, or they're also called as tri-LMs, are at a billion plus parameter scale, have offered the best performance for their size or bits over float LM. When we say float LM, it means floating point 16 representation of the neural network. At 3.9 billion parameter, tri-LM, and I am talking about this model. Tri-LM 3.9, this is a ternary language model, and this matches the performance of 3.9 billion parameter float LM, which is represented in floating point 16 bits. So just imagine that tri-LMs or ternary language models are now competing with this floating point 16 models. Now, before I go into further details of these models and we see how to get them installed, first let me give a huge shout out to Massed Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on good prices, please check the video's description. I have not only given their website link but also a coupon code of 50% discount on a range of GPUs. Okay, so let's also get this thing installed, both of these models, and then we will also see the performance. But before that, allow me to explain in little bit more detail the difference and why this FP16 and this ternary is important. When we say that an AI model is FP16 or even FP32, it means or it refers to the precision format used for the model's numerical computations. All of these neural networks are nothing but some numbers, some vectors. FP32 and FP16 are IEEE standards for floating point arithmetic, where FP stands for floating point and the number represents the number of bits used to represent the mantissa or precision of the network. FP32 uses 32-bit, providing a larger range and higher precision, whereas FP16 uses 16-bit, resulting in a low precision but faster computation and lower memory requirement. But even with FP16, there is still a lot of memory to be consumed. Using lower precision like FP16 or that can speed up AI computation but may lead to reduced accuracy. Now, a ternary AI model refers to a neural network that uses ternary weights, meaning the model weights can have only three possible values: -1, 0, and +1. And this is really in contrast to these FP16 and FP32. Ternary models or tri-LMs are a type of quantized neural network which aims to reduce the model's precision to decrease computational resources, memory usage, and energy consumption while maintaining acceptable accuracy. And they are very useful for deploying AI on resource constrained devices or edge devices. Now, coming back to a bit more detail on this model, the thing is that post-training quantization is the leading method for addressing memory-related bottlenecks in LLM inference. You have seen me using that. For example, whenever a new model is released like 70 billion or even 20 billion, I don't have the GPU to run it in full. So what I do, I launch my LM Studio, I go with the best quant available or quantization model available, which will fit on my GPU. But the problem is that whenever we use that, we also face significant performance degradation, especially when we use it below 4-bit precision. And so instead of doing that, what this ternary LM does, it just trains and openly uh, train the model on ternary scale. So Now what happens is that these proposed ternary models of a given size, they match half precision model at scale. For example, this Tri-LM 3.9 billion, which we are going to shortly install, which is smaller than the half precision float LM 830 million, but matches half precision float LM 3.9 billion, which is really amazing. So same size, but this one occupies less memory but performs the same. That is what I'm trying to say. Okay, so that said and done, let me launch my terminal. You can see that I am running Ubuntu 22.04 and I have one GPU card of 48 GB of VRAM. Let me clear the screen and let me paste the Conda command to create a Conda environment. I'm just calling it Spectra. Let's wait for it to get installed. Shouldn't take too long now. And then we are going to install Transformers library and Torch here. So let me install it. This is going to take a bit of a time, so let's wait for it to finish installing, and then we are going to launch our Jupyter Notebook in the browser and we will install the model there. All the prerequisites are done. Let me launch this Conda Jupyter Notebook. It is going to launch it in the browser. So let's wait for it to get launched. So my Jupyter Notebook is installed and launched. Let's import the libraries and specify our Spectra Suite LM. You can ignore this warning. That is done. So here we are defining the Hugging Face pipeline and we are getting the tri or ternary model. And you might have noticed that I'm using the data type as float 16. But this is not a floating point 16 model, by the way. So what we are doing here, we are unpacking it to floating point 16 format just to make it compatible with transformers. The ternary weights are converted to a 16-bit floating point. The size remains as per ternary one. So, and once it is unpacked, it becomes compatible with Llama model architecture. So this implies that these models, after unpacking, share the same structural design, but Tri-LM or ternary LM was originally optimized for ternary weights to a reduced computational requirement. So that is what is happening here. I'm using device map is auto, which means that if it is CPU, it is going to select CPU. But as I'm using GPU, so it is going to be on the GPU. So let me run it. And there you go. You can see that it is downloading the tensors of the model, which are around, I guess, 10 gig. Also, there was a typo in the above command. You need to use model underscore name instead of model underscore ID. Okay, so let's wait for it to get downloaded and then we will proceed further. And the model is downloaded. Now, one thing to make sure that these are the pre-trained base models. These are not instruction tuned or chat fine tuned. So don't expect any mega responses from them. We are just checking out their response and their performance. So once you run the pipeline with Hugging Face, you can ignore this warning. You see, once upon a time there was a little girl who loved to play with her dolls and all that stuff. So this is your Tri-LM, just done pre-trained on a ternary weights. Now similarly, let's try to uh, use our float LM now. So this is a float LM which we are going to use now, and we will see its response. So in the same Conda environment, I have opened another notebook and now I have just given it float LM 3.9 billion. If you remember previously, we were using the Tri-LM, as you can see here, but this time I am using the float LM. So let me specify it. That is done. And now let's give it the pipeline. And I'm just going to fix their typo which they have on their Hugging Face page. Let's call it model underscore name. And then we are going to download it. Hopefully my 48 GB VRAM GPU would be able to sustain both of these models at the same time. If not, I'll just flush the GPU, but let's wait for it to see how it goes. Let's wait for it to get downloaded. Okay, so thankfully the second model is also downloaded and loaded on to our GPU, which is great. Let's try it out with this one. I'm running it, and then you see once upon a time there was a little girl who lived in a little house with her parents, and so both are coherent. And if you look at the previous one again, this was also amazing. It and didn't hallucinate, didn't print out gibberish. So it looks really good, and the performance was also quite good. Let's try out few more small prompts because this is a base model. Now in the second completion example, let's say happiness is combination of, let's see, this is happiness and happiness. Let's try out this one, what it says. Let me run it. Again, happiness is combination of happiness and sadness. So you see, both base models, don't expect them to be of producing any very legit responses, but you see there is no difference between ternary LMs and the float LMs. Now in the next example, I am giving it another well-known sentence like quick brown fox jumps over the lazy dog. Model should have been trained on this. Yeah, so quick brown fox jumps over the lazy dog, so it knows that. How about if I say lazy, just will it complete or not? Let's run it. Lazy dog, so it knows that. That is good. Let's try out here. I'm just going to remove the lazy dog and let's run it now. Yep, it was able to do it. How about if I just go with this, the quick brown, maybe I'll just, maybe fox, otherwise it will be too hard for the model. The quick brown fox, let's see if it completes it. Yep, you see it was able to complete it. The ternary one, and I'm sure it would be also do that. Let's check it out. Yes, it can also complete it. Let's make it more shorter. How about if I just say quick brown? Let's run it. Yes, still it is able to do it. And how about if I do the quick? No, you see, after quick it is just not able to do it, and it is saying the quickest way to get to the top of the list is to be the first to respond to. Okay, let's try this one, that how it goes. The quick brown, yep, so quick brown is fine. What, let's see if it is able to do the completion or not. No, the quickest way to get to the top of mountain is to take the cable car. So whether you try out the floating point 16, which is the higher precision, or just the ternary LM, performance is the same, the quality is same, so which is really amazing. And as I said, if you go to the Hugging Face page of this, they have done some, they've released 18 models so far, I think 17 or 18, and there are in total 54 models which will be coming up in coming days, and this is the highest one, 3.9. If you look here, they have 830 million, 560 million, 390 million, 190 million, and just simply 99 million. Let me show you that. Maybe I'll just go the size, just want to check the size of the 99 million one. This one, unpacked one. Let's go to files. Look at the size, just 200 MB size of model. It can even fit on your fingernail. So really amazing stuff. Very happy about it, and I'll be trying it out more. Maybe we'll also do a fine-tuning video on a custom data set with these models. So stay tuned. I hope that you enjoyed it. Let me know what do you think. If you like the content, please consider subscribing to the channel, and if you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.